Hello, this is teacher Badru, reminding you of the SOPs, standard operating procedures. Remember, this is a COVID era, so we need to be very vigilant. Wear your mask while in public. Keep a distance of 2 meters away from your neighbor and sanitize oftenly. Going straight to our topic, carbon chemistry. Carbon is an element, sixth in the periodic table because it has atomic number 6. Electron configuration of carbon is 2 to 4, implying it belongs to group 4 of the periodic table because it has 4 electrons in the outermost shell. It belongs to period 2 of the periodic table because it has 2 energy levels. The valence of carbon is 4, implying that in all its compounds, it exercises a valence of 4 since it gains 4 electrons to acquire stability. Occurrence of carbon. Where do we find carbon? Carbon exists naturally in free state and also in combined state. In combined state, carbon exists in compounds such as carbonates, hydrogen carbonates, hydrocarbons, carbon dioxide, which is a gas in air. It is also a component of plant and animal cells, especially in proteins and carbohydrates that make up these cells. In free state, carbon exists as diamond, graphite, and also in the amorphous form. This implies, therefore, carbon is an allotropic element. Allotropy is the existence of an element in more than one form without change of state. The different forms of an element are called allotropes. Carbon has both crystalline forms or allotropes and also non-crystalline forms or amorphous forms. The 2 crystalline forms of carbon are diamond and graphite. Beginning with diamond, its structure. Diamond is made of carbon atoms only, and these carbon atoms occupy the corners of a regular tetrahedron. Each carbon atom is bonded to 4 other carbon atoms in a tetrahedral shape. Because each carbon atom is bonded to 4 other carbon atoms, it implies that all the 4 electrons in the outermost shell of carbon are used for bonding. This implies, therefore, diamond lacks free or mobile electrons, the reason why it is a non-conductor of electricity. Graphite is also a crystalline form of carbon. However, it is made of hexagonal layers. Each carbon atom is at the corner of a regular hexagon, bonded to 3 other carbon atoms by strong covalent bonds. This implies, therefore, carbon uses 3 electrons to form 3 covalent bonds with other carbon atoms, leaving the 4th electron unused for bonding. For that reason, the unused electron is delocalized, is freely moving, and this enables graphite to conduct heat and electricity. So, having looked at the crystalline forms of carbon, diamond, and graphite, we can look at their uses. Diamond is a good conductor of electricity, and for that reason, it is used as an electrode during electrolysis, and it is also used in car batteries. The reason is it possesses delocalized or freely moving electrons. Because we said that diamond is made of layers, and the layers are held by weak van der Waals forces of attraction, the layers slide over each other, this enables diamond to be soft and slippery, and therefore it is used as a lubricant. Because diamond is soft and black in color, it is used to make lead pencils because it can write on paper. On the other hand, diamond is a non-conductor of electricity since it lacks delocalized electrons. It is one of the hardest substances known and therefore used for drilling. Because of its brilliant sparkling luster, it is used in jewelry. The amorphous forms of carbon, amorphous meaning they lack form or they lack a regular shape, include cork, charcoal, soot, or lamp black. I'll begin with charcoal. Charcoal is of two forms. We have wood charcoal and animal charcoal. Wood charcoal is got from destructive distillation of wood. This means burning wood in absence of air. Animal charcoal is got from destructive distillation of animal parts, such as horns and hooves. Charcoal is porous and light. It has pores, and it is also black and opaque. For that reason, therefore, we use charcoal in gas masks to absorb poisonous gases in air and also in stomach. An example is charcoal tablets. Wood charcoal readily burns, producing a lot of heat, and for that reason it is used as a fuel in homes for cooking. Animal charcoal, on the other hand, is used in absorbing colored matter in brown sugar to make it white. The other form of amorphous carbon is soot. Soot is got by burning fuels in limited air, such as diesel, kerosene, petrol, and is used to make shoe polish and carbon paper. Another form of amorphous carbon is cork. Cork is obtained from destructive distillation of coal. It is the solid left after destructive distillation of coal. Cork, just like charcoal, produces a lot of heat when burnt and therefore is a fuel. It is also commonly used as a reducing agent in the extraction of metals, for example, iron in the blast furnace. Other uses of carbon. Carbon can be used to produce coal gas, can also be used to produce producer gas and water gas. To be precise, water gas is made when steam is passed over red hot coke or carbon, producing a mixture of carbon monoxide gas and hydrogen gas. These gases readily burn, producing a lot of heat. Therefore, water gas is used as a fuel. Producer gas, on the other hand, is produced when air is passed over red hot coke, producing carbon monoxide and nitrogen. So a mixture of carbon monoxide and nitrogen makes producer gas. Carbon monoxide also produces heat when burnt from carbon dioxide, and therefore producer gas is also fuel. Thank you very much for listening. May God bless you.